Px is equal to 0. Is a scalar multiple of 25431 transpose. 25431 transpose. Then the rank of P is equal to des. So this is the computer science question, my dear. Computer science question. See this base, independent number of independent vector concept जो भी होता है, that is very important for computer science students, because it is a very good concept for in the case of data science. So data science is the area which is very familiar to everyone, and this is the new trend and technology. So in the field of data science, so you must know the many mathematical terms. So in that, one of them is this. So the number of independent solutions of the system, or the number of independent vectors in a set of vectors. Okay. So nullity concept. These are all the things are very important. How the rank is 1? Subhi Goyal. Okay. Subhi Goyal will ask the question, one question 10 times. Because he has such kind of phobia that, you know, if sir miss my question, then I will not be able to answer it, right? Okay, so that's what the thing here. Anyway, so look into this 32 question, my dear, 32 question. So the matrix, I told you to write the matrix, right? I told you to write the matrix. So what is the matrix? It is 3 3 3 3 3 3 3 3 3 3 3 3 3 3 3 3 3 3 3 3 3 3 3 3 3 3, right? So this is the matrix here we have here, right? Is right. Now, since I can straight away say one thing here. See, how many of them are independent among this, right? See, the number of independent vectors will be at least one. At least one. It cannot be 0. So therefore, here, see, there are 4 are there. Since all the vectors are multiple of only one vector, since all the 4 vectors are scalar multiple of only one vector, that is 3 3 3 3 3. So therefore the number of independent vectors is equal to only 1. Only 1. So therefore the rank of this A is equal to 1. This is the concept for the 32 question. Those who are want to understand how the rank is 1 for the 32 question, you can see it very clearly. I wrote it very clearly that there are 4 vectors, all the 4 are written. See that R2 is equal to R1, R3 is equal to R1, R4 is equal to R1. So this is one linear dependency. This is one linear dependency. This is one linear dependency. So here, so if I take, these are all dependent on, see, R2, R3, R4 are dependent on R1. So therefore, R1 is the only one vector left. So therefore, R1 itself is independent. Okay. So to check the linear dependency, we must have at least 2 vectors. But among all the 4, already 3 are dependent. So we are left with only one vector. So therefore, here that one vector must be taken as independent itself. So again, I am telling you, to check the linear dependency, at least we must have two vectors. But here we have only one vector. So that itself is a independent vector. So therefore, out of the 4, so these 3 are dependent on, these 3 are dependent. And this is independent, because the rank must be at least 1. At least 1. So by taking this one as independent, so the rank is 1. So rank is 1 here. So why we have taken? Because in this case, all the 4 vectors are equal to only one vector. Or you can understand, all the 4 vectors are scalar multiple of only one vector. So then So since all are scalar multiple of only one vector means according to linear dependency, so this the one vector itself is a independent and baki sub dependent. Yes, Harshavardhan, correct. Now, see, there is a terminology, my dear. There is a terminology. So, what is that terminology? Please understand this. Here, what I told you, here, all the vectors are scalar multiple of only one vector. So, then, how many independent I took? One I took. Correct or not? Number of independent is one here. Okay. So, now in this question, you see that, all of you. So in this question, you see that here P is a 4 by 4 matrix here, right? Such that every solution, or that means here X is the scalar multiple of only one vector, that is 2, 5, 4, 3, 1. Write it here. K belongs to R. So X is equal to K times of 2, 5, 4, 3, 1 here. So X is equal to K times of 2, 5, 4, 3, 1, where K belongs to R here. So he said every solution is what? Solution means X. Solution means X not equal to 0. So that X is a scalar multiple of these vectors. So X is equal to set of all these vectors. X is nothing but set of all the vectors. All those vectors are scalar multiple of only one vector. So if this is the solution of solution space of Px is equal to 0, so then the number of independent solutions, that is equal to nullity, is equal to only 1. Nullity is equal to 1 here. Nullity is equal to 1. So therefore here nullity is equal to here number of columns of P minus rank of P. Now nullity is 1 and number of columns are 5. So 5 minus rank of P here. So therefore the rank of P is given by here, that is 5 minus 1, that is 4 here. That is 4. So this is the answer for this question. So the answer for this question is 4. The dimension of set of vectors is 1 in this solution. Yes, Priyatosh, correct. Okay. Rank of P is 4. Dhruv Chatter, your wrong answer. क्यों बेटा ध्रुव आप गलत कर रहे हैं क्यों? सलील खन्ना करेक्ट बेटा करेक्ट. भावना रैंक ऑफ पी इज 4. चिन्मय रैंक इज 4 बेटा 1 नहीं होता. I made R2, R3, R4 as 0, then only one row is non-zero, that's why. Yes, Subi Goyal, you are right, my dear student. Yes, you are right. Only one row is a non-zero row, so therefore according to echelon form, the rank is 1. Very good, Subi Goyal. Can't see someone is asking that. Sir, I wrote the answer of nullity n. Got confused. Okay, no issue. Chinmay Srivastava. Sir, how nullity becomes 1 here? See that. He said very clear. Every solution is scalar multiple of only one solution. So, all the solutions are given by only one vector, na? See. Arey yaar. See this point. All 4 vectors are scalar multiple of only one vector. The number of independent vectors is 1. So, here these vectors. But here it is what? Here it is what? Every solution vector is a scalar multiple of only one vector. So, therefore, all these solutions are all dependent. Only one independent vector is there. One independent solution is there. One independent solution means nullity is 1. See here, please underline this term. It is not every vector, beta. It is every solution. Solution. Every solution vector is a scalar multiple of only one vector. That means all the solutions are given by scalar multiple of only one vector. That's what I wrote. See that. All the solution X, this is the null space. Null space. So is given by scalar multiple of only one vector. So then, so E is a solution space. See, set of all these solutions is the solution space of A Px is equal to 0. If this is the solution space, now what is the nullity? Nullity means the number of independent solutions among these infinitely many solutions. So only one, because all are given by scalar multiple of one vector. Okay. So since if any vector is given by scalar multiple of other vector, then it is a dependent vector or not? Yes. So all the vectors are given by this vector means all those vectors are dependent. Only this one is independent. So this is the independent solution. Therefore, number of independent solutions, which is nullity, is equal to 1. So nullity is equal to 1. The rest of the thing you understood. Sir, in infinitely many solutions, we have only one zero solution and the remaining non-zero solutions. Yes. Sir, a given set of vectors can be treated as matrix only, right? Asking this in relation to dimension definition. See. Here he mentioned solution of Px is equal to 0 means it is the solution X, capital X. Capital X is not a matrix. Capital X is a solution space. It is having set of solutions. Okay, fine. Now let's move on to the next concept, that is, sir, number of column is why not 3 here? Ritan Das. Number of solutions कितना है? Number of columns of P कितना है? 5 ना, 5 नंबर ऑफ कॉलम्स आर देयर, 3 कहाँ से होता है, ये 5 है। क्या पढ़ रहे हैं बेटा? ओके 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 ओके, लीव इट लीव इट। Ritan Das, your question is very illogical and it's not related to it, I feel. Because the P is 4 by 5 is given, na? So 5 number of columns are there for P matrix. Acha, you have written wrong question. Okay, no issue. Okay, fine. Right. Next. Yes. Now I am going into the concept of eigenvalues and eigenvectors here. Yeah, please down. Harshavardhan Reddy, I appreciate that the effort which you have given for 20-second question and you have got 4 by 5, but according to me, it should be 1 by 5. There might be a small calculation error. Don't think otherwise, because the lambda alpha is existing in only one row. So definitely alpha value only 1. It cannot be more than 1. That's a simple common sense I wanted to say. But if the alpha is existing in all the 3 rows, na, so that means the alpha may be possible of 3 values. If it is existing in 2 rows or 2 columns or 2 rows, so then it may be of alpha square term you may get. So therefore, 2 alpha values you may get for the mod A is equal to 0. But since alpha is existing in only one row or one equation, so therefore, so alpha possible values for the mod A is equal to 0 is going to be only 1. So the answer is 1. The effort you have put down is absolutely appreciated, and only a small calculation error you might have got, Mr. Arshavardhan Reddy. चलो बेटा, मानवीश जिंदाल. So dimensions definition, if number of independent solution, number of not independent. अरे जिंदाल सुनो बेटा, एक्स में नंबर ऑफ इंडिपेंडेंट वेक्टर्स को हम नलिटी कहते हैं, और p इंटू एक्स इक्वल टू 0 ना. अगर इसमें जो x में जो होता है नंबर ऑफ इंडिपेंडेंट ऑफ x is nothing but the nullity. Okay, right. When it comes to the matrix here p, so the in p the number of independent vectors in p is the rank of p, is the rank of p here. That is what this is for the this nullity is for the number of independent solutions for x. If you are talking about x, it is the number of independent solutions. If you talk about p, it is the rank of p. That's it. चलो बेटा, आइगन वैल्यूज आइगन वेक्टर्स पढ़ते हैं. राइट. Thank you, Munib. Sekran, yes, even I want to increase the speed, but some cases I need to get slow down because you people have to get connected to the so many things which I have already discussed. So, okay. So, I think, right. Please write down this. Please write down this here, all of you. Right. Yes, you have copied. Right, fine. So here let A be a n by n matrix. I am here itself I am saying that it's a square matrix, right? Okay. For any scalar lambda, there exists a non-zero vector such that Ax is equal to lambda x. Suppose for any scalar lambda, if you can write the A into a non-zero vector x is equal to lambda times of that same vector, so then we can call this lambda is as eigenvalue here, and this x is called the eigenvector corresponding to the this eigenvalue lambda, because if this lambda changes, x also get changes here. So that's what the thing. Anyway, so whenever, suppose if I write some Ax is equal to 3x is set, okay, where x not equal to 0 I say. So that means this 3 is a lambda. This 3 is the lambda, that is eigenvalue. As simple as that, right? So that's what the definition here it is. So whenever the matrix multiplication of one vector, whenever matrix multiplication of a vector is equal to some scalar times of the same vector. Matrix left side is matrix multiple of that vector, but right side is a scalar multiple of that vector. So it is very clearly seen from this expression that a simple scalar is replacing this matrix A, because here both are getting equal, na? So this side it is a matrix multiplication, but that side is a scalar multiplication. So therefore this scalar is characterizing this matrix A. So therefore this lambda is called as characteristic value. What is that? The lambda is also called as the characteristic value or eigenvalue. Characteristic value of A. The lambda is called the characteristic value of A here. I hope you understand. So that's what the thing here, right? Now, okay dear, generally we all know that Ax is equal to y. Please understand, my dear students, I just wanted to give you a small inception here so that you can able to get connected to the topic exactly what is eigenvalue and eigenvector. If not, don't worry, this expression is enough to understand eigenvalue, eigenvector, right? So if you do not have the much basics, so stop it here, okay? But if you want to listen more, then look at here. So generally what happens, linear transformation, when you are multiplying the matrix A to a vector x and you are getting a new vector, correct or not? That new vector can be in generally anything here. It might be anything. It depends on the matrix A which you are multiplying it, correct? Right. Just like you are rotating, or you are making it reflection, or you are taking translation, and you are taking what kind of transformation you are applying on A x, so that x is transformed into some other vector y. So that's called the linear transformation we understand in terms of matrices, right? Okay, fine. But suppose in some cases that if Ax is getting lambda times of x, that means this transformed vector y is can be written as lambda times of x here. Lambda times of the same vector, if you can write, So that means, so this lambda is called the eigenvalue of this matrix here. So this is a special case of linear transformation. So a matrix A is transforming one vector into vector X into another vector which is scalar times of that vector, or which is proportional to that vector, which is proportional to that vector, okay, which is a scalar times of that vector. Or simply you can say this vector getting scaled. EC electrical students, you can understand this terminology. You can see that the vector is getting scaled here. Scaled. It is getting enlarged, or it can be shrink here. So in this field, suppose if this vector X is there, so this is the vector X here. Now it is transforming into, see, the same direction you have here. Okay, same vector it is, but with a different length. It is the same vector, but with a different length here. So it is, so this is nothing but the lambda times of X. So if it is a length 2, so then this length will be of 4 or 8 or multiple of 2, right? ऐसा होता है. So the vector can be shrinked or it can be enlarged, or in technical terms I say that it is just scaled. It is just scaled up. So like that. So here the matrix A is, if any vector is getting scaled, okay, under the matrix A, so then that scaling factor of that vector is called as, the scaling factor is called as the eigenvalue, and the vector is called as the eigenvector, and the vector is called as the eigenvector here. Okay, and the vector is called as the eigenvector. The scaling factor is called as the eigenvalue. All the vectors of A will not do that. Only few vectors of A, few vectors X of A, okay, which is getting scaled up under the transformation, under the linear transformation. So then in the scaling factor, how many times that vector is getting scaled? So that is nothing but the lambda, which is eigenvalue or characteristic value of the square matrix, and the corresponding vector is called as the eigenvector. This is the geometrical understanding of eigenvalue and eigenvector. Okay. Okay, beta. So I think everybody understood this. So now let's find out how do you find out the eigenvalue and eigenvector here. How do you find the finding lambda? चलो lambda कैसे निकालना है? Let us understand. Let lambda be the eigenvalue of A. Let lambda be the eigenvalue of A. Okay. So then Ax is equal to lambda times of X. Let lambda be the eigenvalue of A. So then Ax is equal to lambda times of X. Ax is equal to lambda times of X here. This is the matrix here. Ax is equal to lambda times of vector. Okay. And because lambda is the eigenvalue of A, according to the definition of eigenvalue, so Ax can be written as lambda x, right? Now, dear students, this can be written as Ax minus lambda Ix is equal to 0, because this is matrix multiple and this is a scalar multiple. If you want to subtract with this, so convert this lambda x into matrix form as lambda Ix. So therefore, this can be written as this side as lambda Ix. So then hence it can be written as A minus lambda I into X is equal to 0. So this is what? It is the homogeneous system. Please understand this. So this is for a given lambda. So A minus lambda I is just a B matrix B, suppose. So then it is Bx is equal to 0, which is a homogeneous system, right? But you know, according to the definition, this X is not equal to 0 or not? Yes. Since X is not equal to 0, so this X is called as, this X is what? The solution space of this homogeneous system, right? But this solution space of homogeneous system is a non-zero solution space, right or not? Non-zero solution space. Now you tell me, when do you have the non-zero solution for homogeneous system? So this implies that now I say this homogeneous system is having non-zero solutions. So this homogeneous system is having non-zero solutions means, so then the system will have infinitely many solutions or not? Non-zero, sorry, this homogeneous system is having non-zero solutions means infinitely many solutions. Infinitely many solutions means then the determinant of this coefficient matrix will be 0 or not? Yes. So therefore this implies mod of A minus lambda I is equal to 0. Now dear students, A I know, I know, but I don't know lambda here. So now, so this generally mod f minus lambda is equal to 0 is generally you will get that f of lambda is equal to 0. Now solving this equation, so we get the lambda. We get lambda here. So where this lambda is the eigenvalue of A. Where this lambda is the eigenvalue of A here. Okay, fine. So this is how we will be finding the eigenvalues of a given matrix. This is what the given eigenvalues of the given matrix here. Now let us see that how do you find the eigenvectors, that is x not equal to 0, right? Okay. Dear students, according to the definition, what is an eigenvector? Eigenvector is nothing but it is the solution of this homogeneous system, right? So eigenvector, since eigenvector is the non-zero solution, is the non-zero solution of the homogeneous system A minus lambda I into x is equal to 0 here, right? So eigenvector is a non-zero solution to this homogeneous system here. I hope you understand, right? Okay. Okay, then substitute this lambda into A minus lambda I into x is equal to 0. Then solving only the independent equations, we get the x not equal to 0. So this is how you are solving the eigenvector here. This is how you are solving the eigenvector. Yes. Yes, Devansh. Yes. Gaurav Kumar, it is the condition for infinitely many solutions. The condition for non-zero solution is determinant of the quotient matrix is 0. The quotient matrix is A minus lambda I. Gaurav. See, this is what? This is the procedure of finding the eigenvectors. Finding the eigenvectors. Now we'll do a question here. Exactly, I will show you how do you find out the eigenvalues and eigenvectors for a given matrix. Okay. Find eigenvalues and eigenvectors of 2 1 1 1 2 1 0 0 1. So this is the question. Now let's solve this, all of you. Acha, see, wait a minute, all of you. See, this is called the characteristic equation of A beta. Characteristic equation of A n by n. See, all of you, please make a note of this. I think I forgot to write this. So please make a note of this. Here, right, the determinant of A minus lambda is equal to 0. That is f of lambda is equal to this equation, which is giving you characteristic values, is called as characteristic equation of A n by n. Please remember this. Solving the equations, Manvish. Manvish, solving the equations. See, substitute lambda into this. Once you substitute lambda into this, solving the independent equations. Solving means what? Solving the independent equations. So the equations you will be getting from this system after putting lambda. Kabhi kiye nahi beta? Huh? ये characteristic equation of A n by n beta. Please mention this. This is very important. Characteristic equation of A n by n is mod of A minus lambda is equal to 0. Right. All of you, just I want to find out the eigenvalues and eigenvector for a given matrix here. First, I have to find the eigenvalues. My question to you that how do you find the eigenvalues of a given matrix? See, my dear students, yes, the eigenvalues are we are getting by solving the mod of A minus lambda is equal to 0. So find out A minus lambda I and take the determinant is equal to 0. We will get an equation in lambda. So then solving that, we are going to get the eigenvalues here. Now, first we will do this procedure. First we will find the eigenvalues. First we will find the eigenvalues here. Yes. Lambda are given by the characteristic equation of A, that is mod of A minus lambda I is equal to 0. Yes, what is that mod of A minus lambda I is equal to 0? All of you, how do you write this A minus lambda I? Is very, very simple. Subtract the lambda from diagonal elements and keep other elements as it is. 2 minus lambda, 2 minus lambda, 1 minus lambda, 1, 1, 1. Okay, 1, 0, 0 here. Right? So this is what, and the determinant is equal to 0 here. Right, this determinant. Dear students, I want to solve this differential equation. Sorry, determinant. But here, the techniques, you have to use the technique to find out the determinant as simple as that here. How? By fixing the arrow which is having maximum number of zeros. So here we have plus, minus, plus here. So therefore, I can take it as here. And I can take it as here 1 minus lambda into this minor, right or not? 1 minus lambda into its minor is this. So that is 2 minus lambda whole square minus 1 square is equal to 0 here. So this gives you 1 minus lambda into here. What is this? A square minus B square can be written as A minus B into A plus B is equal to 0 here. Now, the 1 minus lambda into, and what is this? It is 2 minus 1 is 1. 1 minus lambda, and this is 2 plus 1, 3. So it is 3 minus lambda is equal to 0 here. So therefore, here 1 minus lambda is equal to 0. 1 minus lambda is equal to 0. 3 minus lambda is equal to 0. So lambda is equal to 1, lambda is equal to 1, lambda is equal to 3. So these are the eigenvalues of the matrix here. Okay, now we have to find the eigenvectors. So let us find the eigenvectors x not equal to 0 here. Right. So now, dear students, I told you as per the definition, for each eigenvalue, we will find out the eigenvectors. So therefore, for every lambda, you have to find the eigenvectors. Okay. So now, what is the procedure of solving the eigenvalues, eigenvector? Please see that. Substitute the lambda into a minus lambda into x equal to 0. Then solving only one independent equation will get x not equal to 0 here. We'll get x not equal to 0. Right. Now, first case, let lambda 1 is equal to 3. Right. Let's go with this 3. Lambda 1 is equal to 3. Right. Now, substitute lambda 1 is equal to 3 in a minus lambda I into x is equal to 0. A minus lambda into x is equal to 0. Right. Okay. Let's take a minus lambda I. What is a minus lambda I? This is what a minus lambda I. Now you put a lambda is equal to 3 in it. What is 2 minus 3? Minus 1. 2 minus 3? Minus 1. 1 minus 3? Minus 2. So it becomes minus 1, 1, 1 minus 1, 1 and 0, 0 minus 2. Right? Put lambda is equal to 3. So then into here x, y, z is equal to 0, 0, 0. So this is the a minus lambda homogeneous system. Homogeneous system for lambda is equal to 3. Substitute the lambda is equal to 3 in a minus lambda I so that you are getting this into x is equal to 0. Now, how many equations we will have, Manvish? Manvish, how many equations you can have? 1, 2, then 3. But here all the 3 equations cannot be independent because you have already seen the determinant of this a minus 3i is 0. Already determinant of a minus 3i is equal to 0 or not? So therefore, so this matrix do not have all are independent. So at least one will be dependent. At least one will be dependent. So let us check. Let us take only 2 independent equations. Now, any 2 you take. So the ratio is minus 1, the ratio is minus 1, the ratio is 1. So since the ratio of the first 2 equations are not same, so therefore what I do is that I will consider these 2 as a independent equations. Okay, so that this is going to be a dependent one. Again I am telling you, since mod of a minus 3i, since mod of a minus 3i, a minus lambda I for lambda is equal to 3, it is 0. So if the determinant is 0 means at least one equation will be dependent or not? Yes. So out of 3 equation, one will be dependent or at least one will be dependent. Now, if you fix any one of them is dependent here and you take the remaining 2 and apply the apply the ratio and see that the ratios are not equal means yes, there are 2 independent equations we have. So therefore, we write solving the independent equation. Solving independent equations in it, right? So for that, minus x plus y plus z is equal to 0 and x minus y plus z is equal to 0 here, right? So these are the equations, my dear. Now, how do you solve these equations? How do you solve this equation 1 and 2 here? Now, solving 1 and 2. Solving 1 and 2. How? Let's see, all of you, please understand the new concept here, that is x, y, z here. A technique I am telling you, So please take these values with this technique. So how do you solve the 2 equations in 3 unknowns? Whenever we have 3 unknowns and 2 equations, then how do you solve those equations very easily is this method. See, x, y, z. And now, start taking the coefficients from y. Start taking the quotient of y. Start taking from the coefficient of y, and other coefficients are also taken in this order till you repeat y coefficient. Now start from the y coefficient. Yes, what is the y coefficient in the first equation? That is 1. So put 1 here. Next, after y coefficient, then z coefficient is 1 here. Put 1 here. Then after z coefficient, then x coefficient, it is -1. Put -1 here. Then after x coefficient, it is y coefficient again. So 1 here. So started with y coefficient and ended with y coefficient. Similarly, we have to do for the second equation also. Now start from the y coefficient and take the coefficients in this order. Now -1, 1, 1, -1. Right? So this is the order you are taking it. Now my dear students, here, how do you take this x here? The determinant of this is we are taking x divided by the determinant of these first two columns, that is 1 minus of -1, that is 2, that is equal to here. Next, y. Let's take y. So y means the determinant of these two, that is 1 minus of -1, that is 2 here. Next, here, then again we'll take the blue. So then here z by the determinant of these two, that is 1 minus 1 is of 0. So 2 ones are 2 ones are 2 zeros are is equal to some constant k, suppose. So therefore here capital X is equal to x, y, z. We write it as, all of you please look at this, x is equal to what? 1 into k. So that is k. Y is equal to 1 into k. So that is k. Z is equal to 0 into k. So that is 0. So this can be written as k times of 110, where k is any real number. Okay. So this is what the case. This is the procedure of solving this equation. Now, since these three equations, one equation in x, one is in y, one is in z, if when all these three variables expressions are equal, so these are called as auxiliary equation. कभी भी ऐसी equality आ जाता है, so all these three can be equated to some constant k here. So therefore, so x by 1 is equal to what? See, x by 1 is equated to, right, x by 1, right, x by 1 k, x by 1 is equal to k, x by 1 is equal to k, so x is equal to k. Got the point? Similarly, y by 1 is equal to k, so y is equal to k. Similarly, z by 0 is equal to k, so z is equal to 0. So this is the way I have taken x value, y value and z value here, and I am taking k common in this. So then this vector is written as k times of 110. So that means it is very, very clear here, all of you, very clear that this capital X is the eigenvector. What is this capital X is? Yes, as per the definition, what is this capital X is? See. See, what is this capital X is? Capital X is the eigenvector here. Correct or not? Yes. Capital X is the eigenvectors. But now, my dear students, you tell me, is it only one vector or infinite vectors? So these are infinite vectors. So these are infinite eigenvectors. For lambda is equal to 3. There are infinite eigenvectors. We can write k is equal to 1, k is equal to 2, k is equal to 3, k is equal to 4, k is equal to 5. Okay. So there are so many things we can write it here. There are so many things we can write it. So therefore, we'll have an infinite eigenvectors for lambda is equal to 3 you are getting. But my question to you is that, so lastly, I will ask you the question, but now I hope you understand how do you find the eigenvalues? How do you find one eigenvector for lambda is equal to 3? So next I will show you how do you find out the eigenvector for the repeated lambda is equal to 1. Please take it copy. Please copy this. Yes, Chinmay Srivastava, you can take any two independent. Dhruv Charter, I never said 002. No. I'm sorry. Yeah, Dhruv 002. I wrote it as a dependent. Why I wrote it as a dependent? Because since the determinant of a minus 3i is 0, therefore the equations I got for lambda is equal to 3 are having the linear dependency because the determinant is 0. So linear dependency is there means one row is a dependent row or not. So out of 3 rows, one row will be dependent, or out of 3 equations, one equation will be dependent. At least one equation. So when at least one equation is dependent, I consider the third one as a dependent, suppose. Then I check the first 2 equations. In the first 2 equation, I have seen that there is a linear independency. So therefore, I made the third one as a dependent, and I took the first 2 as an independent. Similarly, you can make the first one as a dependent, and you can go for the linear independency of second and third equation also. Okay, you will get the same vector. Srija Mukherjee, you must be very careful when I was doing it. See, I have Srija, you have seen that I have done with the green one I done with the green determinant, and the yellow one I done with the yellow determinant, and blue one I done for the blue determinant. You can see that I have done very clearly. Yes, when you have 2 equations in 3 unknowns equations, 3 unknowns, so then we have to solve in this procedure only. You have to take always y, start from y. Explain infinite eigenvector part, sir. Why? How answer is 3? Answer is 3. Who said answer is 3? Answer is 3. Harsha? Who said answer is 3? Answer is 3. What is answer 3? I don't understand. What answer I wrote it? Selva Kumar. How answer 3? No. You are wrongly understood. Please read it once again. Yes, we should start from y beta. Always. Dhruv Chatter, yes, 2 equation also may be dependent. At least one equation is dependent, na? So when I say at least one, pakka one will be dependent. There is no doubt that one of the equation is going to be dependent compulsorily. So therefore, by ignoring the one equation out of 3, so I am checking the linear dependency among the remaining 2. If there is a dependency, so you should say that yes, second equation or first equation is also a dependent equation. So in that case, we'll have only one equation. See, this method is for only 2 equations, 3 unknowns. That's it. 2 equations, 3 unknowns. Only for this. That's it. Okay. So now I'm going to do for lambda is equal to 1. So find x not equal to 0 for lambda is equal to 1. Chalo, substitute lambda is equal to 1 in a minus lambda I into x is equal to 0 here. So then in that case, what it is going to be? Let's see. A minus lambda. Put lambda is equal to 1 here it is. Now, 2 minus 1, 1, 1 and 1, 1, 1, 0, 0, it's 1, it is 0 into here x, y, z and is equal to 0, 0, 0 here. See, हाँ बहुत लोग कुछ डाउट्स लिख रहा है तो वो डाउट लिख रहा है ना तो यहां पर थोड़ा ध्यान से देखना. प्लीज लुक इनटू दिस इक्वेशंस माय डियर. सी दैट x plus y plus z is equal to 0. x plus y plus z is equal to 0, right? X plus y plus z is equal to 0, or you can wait a minute. So if I say x1, x2 and x3, I say that, right? Okay. Now x1 plus x2 plus x3 is equal to 0. Yes or not? X1 plus x2 plus x3 is equal to 0. You are getting correct? Yes. You are getting that x1 plus x2 plus x3 is equal to 0. Now second equation is also x1 plus x2 plus x3 is equal to 0. Now the last equation is 0 is equal to 0. We do not have. So how many of them are dependent here? So 0 vector is dependent one. So since the ratios are equal, so one of them is dependent one here. So therefore this is taken as independent one, because rank of a non-zero matrix at least one. So that's why the first row is I am taking as independent here. So here this is the way we understand. So that means how many independent equations we can have here? Only one independent equation we have. So we are not getting the two independent equations here. So we are getting only one independent equation. So we have only one independent equation. So how do you solve this? How do you solve this? Now solving this. Now previous procedure which I have given for two equations, three unknowns, but it is not two equations in three unknowns. This is for what? One equation in three unknowns. How do you solve the one equation in three unknowns? Let's see that. The number of free variables are given by number of free variables concept. So what is the number of free variables? I'll tell you. The number of free variables is given by the number of unknowns minus rank of a minus lambda I. Rank of a minus lambda I. Yes, how many unknowns are there? 1, 2, 3. So 3 minus rank of a minus lambda I. So I think this is a minus lambda I. Correct or not? This is a minus lambda I into x equal to 0. So for lambda is equal to 1, what is the rank of this a? This is a dependent, this is a dependent, this is independent. So rank is 1. So rank of this one is 1. So this is equal to 2 here. So what is this 2? Sir, why did you find this 2, sir? Correct? So do you want to know? Just see this. Out of these three variables, how many variables are there? 3 variables. Now, to solve this, we need to take 2 of the variables as, see, the number of free variables, that is 2. So out of these 3 variables, you have to take the 2 variables as some free values. You can assign free values to any 2 variables here. That is what the concept of number of free variables. Suppose if you are getting the number of free variable concept as 1 here, so that means out of these 3 you have to take only one as free values. That means any arbitrary value. Okay, I hope you understand. But here I got 2. So I got 2 means out of the 3 variables I need to take 2 variables as some arbitrary values or free values. So now therefore let x1 is equal to x2 is equal to k1 and x3 is equal to k2. Just a minute. Let x1 is equal to k1, x2 is equal to k2. Okay, I suppose x1 is equal to k1 and x2 is equal to k2. If I substitute x1, so from this what I can get, see that x1 is equal to k1, x2 is equal to k2. If I substitute, then this x3 can be written as here minus k1 minus k2 from this equation. So this equation is giving you this. See, x1 is k1, x2 is k2. So then x3 will be minus x1 minus x2, which is minus k1 minus k2, right? So now, dear students, see how I am writing the solutions. Now, therefore, capital X is equal to x1, x2, x3 here. Now, x1 is what? K1. X2 is what? K2. X3 is what? Minus K1 minus K2 here. Okay. I hope you understand. Now, so this can be written as 1 into K1 plus 0 into K2. Can I write like this? Now, 1 into K2 plus 0 into K1, right? And then this way. So now, my dear students, this X can be, I'm splitting this. I told you in any row or any column, you have this two terms, you can split this. So we can split this in this manner. Now, I write it K1 of, it is 1, it is 0, it is minus 1, plus I'll write K2. K2 of what? 0, 1, and then minus 1. So this is the x1. So now what is this x, my dear? So where k1 comma k2 belongs to R here. So these are infinite the eigenvectors. Infinite eigenvectors for the lambda is equal to 1. For the lambda is equal to 1. So we are getting these infinite eigenvectors. All of you understood here? Everyone? So these is the way you are finding the eigenvalues and eigenvectors here. So please copy this. After this, I'm going to give you some import. I'm going to connect, okay, the nullity concept to the very, very interesting topic in linear algebra, where we are getting the questions in the examination also. I want to show you very exactly that what is that is going to be. Please take down this. Yes, Reshma, you can conclude that lambda is equal to 3 is having infinite eigenvectors. Subhi Goyal is saying that I think you are wrote wrong. You wrote it wrong. R2 and R3 can be independent and R1 is dependent. Okay, thank you. Thank you, Subhi Goyal. Sorry, Subhi Goyal. This is what your understanding power. You are wrong, beta. Subhi Goyal, you are wrong. Subhi Goyal, either you go with your concept or you go with my concept. So then you can learn very effectively. Okay? Any one beta, you choose. You are clever. I can understand. Either you go with yours or you go with mine. Then you will be blessed, I feel. For eigenvalue 1, we are getting only one equation. Correct, Madhav. You are right. Divya Bharati? No. Yes, I think for a variable. Sorry. What if two dependent equations? Anduri Sai, I think your doubt is clear now. Harshavardhan, as the k value can be any number, so we are getting infinitely many vectors. That's why infinite eigenvectors. Ankitwal is asking, sir, always we should take from y. Yes. Manvish, something is writing. Only question, what is the need to split the x? Okay, you will come to know Mr. Manvish. You will come to know Mr. Manvish. Wait for that. Please zoom out the board. ठीक है बेटा, आपके लिए zoom out करेंगे. Yes, Rahul. See, this is not the actual methods for GATE examination. I'll tell you the techniques and shortcuts. See, those who are not understood many things in this, or those who are not clear with this, don't worry. We are not going to do anything with this in our GATE examination. I just want to show you exactly आइगन वैल्यू कैसे होता है, आइगन वेक्टर्स कैसे बनता है, हाउ वो आइगन वेक्टर्स आइगन वैल्यू के लिए कितने आएगा, इन्फिनिट कैसे बनेगा, ओके वो सारे मैं आपको दिखाना चाहता हूं. और how you are solving the equations to get the eigenvectors, and this is one way of solving these two equations in three unknowns. This is one way of solving the number of variable free variable concept, that is the number of unknowns minus rank of a minus lambda high. So hence we are able to see the eigenvector. It is written as this one. This splitting concept क्या है और ये splitting करने से क्या आता है और उससे हमको इन्फिनिट आइगन वेक्टर्स मिल रहा है तो क्या है. सो एवरीथिंग आई एम गोइंग टू गेट कनेक्ट, प्लीज वेट. ओके, सो बट एक्चुअली क्वेश्चन यहाँ ऐसा नहीं पूछेगा. सो दिस वे द क्वेश्चन विल नॉट आस्क इन द एग्जामिनेशन. इट इज जस्ट फॉर योर अंडरस्टैंडिंग पर्पस वी हैव डन. Yes, eigen subspace. Shaurya Bhatnakar, correct. Yes, yes, Saurabh Vishwanath Shilke. This is what I am saying. Since mod of a minus lambda is equal to 0, definitely there is at least one will be dependent equation because the determinant is 0. Sahi. Very good. Now you got my point. अच्छा ठीक है बेटा, जल्दी आ जाएंगे फटाफट. कम टू दिस पॉइंट हियर. So this is what the way you find the eigenvalues and eigenvector, my dear. But my question to you that, yes, this is the solution of, see, this one. Coming to this, see, all of you please look at this one. Now, so while you are finding the eigenvector here, the eigenvector is given by k times of 110. So now my dear students, as a very simple question to all of you is that there are infinite vectors or infinite eigenvectors because of k is equal to 1, k is equal to 2, k is equal to 3. K can be anything here. So therefore you can write here infinite eigenvectors, right? But out of these infinite eigenvectors, how many of them are independent eigenvectors? That is my question. There is a 2 marks question you are going to get in the examination on this. So please tell me, how many of them independent eigenvectors? There are infinite eigenvectors are there, but out of these infinite eigenvectors in this case, how many of them are independent? Please, I have already told you this concept. Anybody? Okay, fine. Now, what do you understand from this one? How many of them are independent eigenvectors? Yes, I'll tell you. For lambda is equal to 3 here, for lambda is equal to 3, all the eigenvectors are given by scalar multiple of only one vector. So therefore, the number of independent eigenvectors is the only one. This is the one independent eigenvector. One independent eigenvector. So I hope you understand. Only one independent eigenvector, because all these are given by scalar multiple of only one eigenvector. So therefore, that one eigenvector itself is a independent, baki sub dependent on this. Okay, very good. So one independent eigenvector. Now, But actually, I just want to say one thing, that I don't know how many of you can understand this concept. I don't know, but I just want to say one thing. See, can I say that these eigenvectors, whatever you are getting the solution here, the eigenvector is the solution of this homogeneous equations or not? Yes, yes or not? So for lambda is equal to 3, right? For lambda is equal to 3 here. Now this capital X is the solution of this homogeneous system, right or not? Yes. If this X is the eigenvector is the solution of this homogeneous system, right? Now so then the eigenvector set is the solution space or null space of this homogeneous system. If this is the null space of this homogeneous system, so what is the nullity of this? What is the nullity of this? The nullity is given by the number of independent solutions of this a minus 3i into x equal to 0. So that number of independent solution is nothing but number of independent eigenvectors. So the number of independent eigenvectors or the number of independent solution of this system is given by the number of unknowns minus the rank of this coefficient matrix a minus lambda I. So therefore, so how many unknowns are there here? X, Y, Z. So 3 unknowns minus what is the rank of a minus 3i? So rank of a minus 3i is 2, because there are two independent equations. So 3 minus 2 is equal to 1. See, the nullity of this homogeneous system you are getting as 1. So where this 1 is nothing but the one independent eigenvector, because here the nullity is nothing but here the independent eigenvectors. I hope you understood. So using the nullity of the homogeneous system concept, so we are able to understand that how many independent eigenvectors you are getting for lambda is equal to 3 here. Okay. So I hope you understand this. So therefore, so I want to conclude one point here. From this, what I have derived here, that is the number of independent eigenvectors x not equal to 0 correspond to the lambda is equal to 3. Okay. Corresponding to lambda, I say, corresponding to given lambda is equal to number of unknowns minus rank of a minus lambda I. This is what you have done. I hope you understand. This is also called as the geometric multiplicity of an eigenvalue lambda. Here. See, this is what I have shown you by the question here. From the question, first of all, you understood that the eigenvector is the solution of a homogeneous system. So among the solution, so how many of them are independent? That means the number of independent solution of that homogeneous system is given by the number of unknowns minus the rank of a minus lambda I, which gives you the number of independent eigenvectors, because the solution of this homogeneous system of a minus lambda into x equal to 0 is nothing but the eigenvector. So here the solution, here the eigenvector, here the independent solution, here the independent eigenvector. So here the nullity, here the geometric multiplicity of lambda. That's what the concept it is. So please, I hope everyone understood. Not minimum, Sandeep. Minimum concept नहीं आएगा. फटाफट करो बेटा, टाइम हो रहा है, 5 बज रहा है, तो मतलब और 45 मिनट्स है, जल्दी जल्दी करो, कुछ नहीं किया आज। प्रॉपर्टीज तो करना है, एटलीस्ट तो प्रॉपर्टीज ऑफ आइगन वैल्यूज टू बी फिनिश्ड ना। आई होप यू अंडरस्टैंड दैट। देखो बेटा, यही तो प्रॉब्लम है, कभी कभी मुझे लगता है ये प्रॉब्लम के हटाएंगे। Better I not to solve this question in the class. So directly I go with the properties and questions and shortcuts and everything. So I feel, but as you know, this the computer science students are going into data science, and they must have some knowledge of mathematics. So for that purpose, they must know all these things here. That is, what is independent eigenvectors, what is a lambda, what is eigenvalue, what is eigenvector, वो geometrically कैसे होता है. So all these are very important. Linear algebra, probability statistics, and calculus part is very very important for data science concepts. Noted and copied. चलो बेटा, अब इस पे आ जाता है, देखो. Now, यहाँ पर देखिए. Now all of you see this, right? This is for lambda is equal to 1. This is for lambda is equal to 1 here, right? Okay. Now, you look at this, my dear, all of you. The eigenvectors are infinite here. Infinite eigenvectors you are getting. So, this is the infinitely many solutions of this homogeneous system. So, if this is a infinitely many solutions of this homogeneous system, here, now, my question is, how many of them are independent? How many of them are independent for the independent solutions for this homogeneous system? Again, these are the infinitely many solutions of this homogeneous system. So then, how many of them are independent solutions? Here, this X is representing what? All the infinitely many solutions, है ना? This is giving you all the infinitely many solutions, correct? But थोड़ा ध्यान से देखना, लीनियर डिपेंडेंसी कॉन्सेप्ट पे जाके देखना. If any vector is given by linear combination of two vectors, then this is a dependent vector or not? So this is a dependent solution. So if this is a dependent solution on these two, so then these two are the independent solutions or not? Let me check. See, this 1 0 minus 1, if you put 1 0 minus 1 in this, what happens? 1 plus 0 minus 1 is getting 0, satisfying or not? So this is one eigenvector. This is one eigenvector. Okay, then I will take 0 1 minus 1. See, 0 1 minus 1. So this is, I am getting 0. So that means, so this is also an eigenvector. This is also an eigenvector. Now here, come on. If these two are the eigenvectors of lambda is equal to 1, because they are satisfying the equation, correct? Okay. So these two are the eigenvectors, but these two are independent or not? See, anyway, this is independent. This is dependent. There is no doubt, because it is given by linear combination of these two. But my question to you, that these two are independent or any dependency is there? I want to check. Is there any linear dependency is there between these two? Let me check. What is the ratio? 1 by 0. What is the ratio? 0 by 1. So ratios are not equal. So that means I can say very, very clearly that, so these two are the independent eigenvectors for lambda is equal to 1. So it is very clear. So all the eigenvectors, or all the infinite eigenvectors, are generated by the linear combination of these two independent eigenvectors. So therefore, all these are dependent, only these two are independent. Hence, for lambda is equal to 1, there are only two independent eigenvectors are there. Or you can also understand, out of the infinitely many solutions of this homogeneous system, we are having only two independent solutions. So nullity is 2. Nullity is 2. So this is what the way nullity is to be understood. बहुत सारा लोगों को nullity क्या होता है पता नहीं, but they only know the formula. They only know the formula. But now I think you understand. So this is a homogeneous system. This is a homogeneous system. For this homogeneous system, we are having infinitely many solutions. Out of this infinitely many solutions, so we are getting only two independent solutions out of the infinitely many solutions. So therefore, the nullity of this homogeneous system is 2. This 2. But now, I told you the nullity of this homogeneous system gives you the geometric multiplicity of lambda. That is, what is geometric multiplicity of lambda beta? यहाँ पर देखना. The geometric multiplicity of lambda is equal to 1. It is equal. Lambda is equal to 1 के लिए क्या है थोड़ा देखना. All of you. Please understand this. Lambda is equal to 1 के लिए क्या है? This geometric multiplicity of an eigenvalue lambda is equal to 1 gives you the number of independent eigenvectors for the lambda is equal to 1. That is given by the nullity formula. What is the nullity formula? Is number of unknowns minus rank of the coefficient matrix. What is the coefficient matrix here? The coefficient matrix is A minus lambda I, where lambda is equal to 1. So for this homogeneous system, the nullity is the number of unknowns minus rank of A minus lambda I. So the same thing I am using here. Here, so that is given by number of unknowns minus rank of A minus 1i. Chalo beta, how many unknowns were there? Unknowns were how many? x1, x2, x3, 3. So 3 minus rank of A minus 1i. What is rank of A minus 1i? Chalo, rank of A minus 1i. See, this is what? See, this is what the A minus 1i. This is A minus 1i, na? Yes. How many of, what is the rank? 1. Because out of these 3, only rank is 1. Rank is 1. So the answer is 2 here. Right? So the geometric multiplicity of lambda is equal to 1 is 2, or the number of independent eigenvectors for lambda is equal to 2. Yes, let's see. How many of them independent eigenvectors? These are all infinite, but these infinite eigenvectors are dependent eigenvectors which are dependent on these two independent eigenvectors. So, two independent eigenvectors. So that too you are getting by this formula here. कभी कभी examination में आपको नहीं, sometimes the question asked in the examination that how many number of eigenvectors per given lambda. That is given by this formula. So this formula is obtained from the concept of nullity. So this derivation of the formula has been derived from this concept with the help of nullity concept. That is one thing. Second thing, you have understood that what is the nullity? What is the dimension of a null space? So how do we see that? Actually, how do we feel that the independent independent solutions among the infinite many solutions, that exactly how they occur in the solution system of equations, that also you have seen here. So all the things are covered. So I hope I have given a lot of effort in making understand this today's concept, whatever I discussed today, so that everything I think I have been shown, visualized very, very clearly. So, and I have derived everything here. So I hope you understood everything. So no problem if you are not understood anything, because there is no need of all this visualization or the feeling and all. But we, as when it comes to mathematics, we need the properties, shortcuts, techniques, formulas and all. Right? Okay. Bhavna, again you are confusing yourself. It is the number of independent eigenvectors. not independent vector. So please read the definition of eigenvector, Bhavana. Please read the definition of eigenvector, then you will understand. Otherwise, leave it. Nothing. Not a problem. Right. I hope that everyone understood this. So this formula has also been taken here. Now let's go with some yes, general characteristic equation here. General characteristic equation of a n by n here is that is a n by n minus lambda I is equal to minus 1 whole power n lambda power n minus 1 whole power n minus 1 into the trace of a into lambda power n minus 1 plus and so on, mod a is equal to 0. Mod a is equal to 0 here, or otherwise I'll write one more term. Yeah, minus 1 whole power n minus 2 into del 1 1 plus del 2 2 plus and so on del nn of lambda power n minus 2 plus and so on plus mod a is equal to 0. Okay, this is what you got it here now. Okay, fine. Thank you, Rahul. Yes, it is necessary to have independent eigenvector, at least one. What if the vectors corresponding to k1 and k2 do not satisfy? Manvish Jindal, such case does not occur. Such case does not occur. Thank you, Vidyabhushan. Thank you, Manvish. Thank you. Sir, can we say number of independent eigenvectors is equal to nullity of a minus lambda I into x is equal to 0, not x is equal to 0. Madhav Mishra. Here, the homogeneous system is a minus lambda I into x equal to 0, not ax is equal to 0. Okay? Right? If it is a minus lambda into x equal to 0, your statement is correct. Delta 1 1. You forgot, huh? Shaurya Bhatnagar. Delta 1 1. Please go back. Go back to the determinant concept and learn delta 1 1 and come back. Trace is there. Sum of diagonal elements is there and determinant is there. ध्रुव चाटर सब पूरा मिक्सअप कर दिया बेटा तुम. इसीलिए प्री एग्जिस्टिंग नॉलेज को यूज नहीं करना बोलता हूं मैं, क्योंकि मेरा जो एक्सप्लेनेशन है, मेरा जो कंटेंट है, मेरा जो टेक्निक्स है, मेरा जो अप्रोचेस है, वो किसी से मैच नहीं करता है बेटा. इफ जनरल क्वेश्चन इट इज ओके, बट माई अप्रोच इज कंप्लीटली डिफरेंट. सो दैट इज वाई आई सेड दैट प्री एग्जिस्टिंग नॉलेज को आप स्विच ऑफ करके रखिए. ओके, otherwise you won't digest my methods. Thank you, Abhishek. Saurya Bhatnagar again is asking what are deltas, sir? What are deltas? ये डेल्टा कौन है बेटा? It's a minor of element A11. It's a minor of an element A11. Sir, what is written in the last line? Okay, I'll explain this. See this. See, this is the general characteristic equation of an by n. Generally an by n का characteristic equation कैसे होगा? देखो बेटा, आपको तो पता है, if A is a n by n matrix, okay, the determinant of an by n minus lambda I will give you an equation in terms of lambda. And since it is a of order n by n matrix, so the equation also you will be getting of degree n. Okay, of degree n. So this is the nth degree equation. This is the nth degree equation. So generally nth degree equation कैसे होगा मैं आपको बताता हूं, सुनिए. The highest coefficient of any nth degree equation will be minus 1 whole power n always. Then next one will be minus 1 whole power n minus 1. Then next one will be minus 1 whole power n minus 2 and so on. Like that it will be, right? In generally, right? But when it comes to characteristic equation of this matrix, so here please understand the coefficient of the highest degree term. So this is the highest degree term. This is the highest degree term for the characteristic equation of an by n. This is the highest degree term and इसका coefficient होता है that is minus 1 whole power n होगा. Okay, this is for the characteristic equation of an by n I am saying. Now the next highest degree, next coefficient of the next highest degree. So this is the next highest degree. So what the coefficient of this one is that minus 1 whole power n minus 1 into trace of a. So this is the coefficient of the next highest degree term. Okay. Then the next highest degree term क्या होगा? That is lambda power n minus 2. So the lambda power n minus 2 का coefficient क्या होगा for this an by n matrix is, that is, yes, minus 1 whole power n minus 1 whole power n minus 1. So the next will be obviously minus 1 whole power n minus 2 into, yes, it is trace. So what is trace beta? A11 plus A22 plus and so on. ANN. Correct or not? This is the trace. Correct or not? But what is this one here? So it is nothing but here the, wait a minute. Sorry. Wait. I'm sorry. Please make a change. No. Wait. Don't take this term. I'm sorry. Don't take this term. You write up to this only. I'm sorry. Only this one. I'm sorry. Right. Only this one, beta. Not the next one. Next one is not correct. Lambda power n minus 2, it is not correct, my dear. Please don't take it. That's it. So this is what here. Now the next term is for lambda power n minus 2 term. So that will be something different. I'll tell you. Then and so on. The last one you are going to get the constant term. So that constant term of this characteristic polynomial is going to be a determinant of this coefficient matrix. So here this one. The coefficient of the highest degree term is minus 1 whole power n. Then the constant term is going to be the constant term of the characteristic polynomial is going to be determinant of A. It's a determinant of A here. So I hope you understand. I'm sorry, beta. So please change it. ये लिखना. I'm sorry. That is different. Now the characteristic equation for 3 by 3 matrix, for A 3 by 3. For A 3 by 3, that is yes. So please take down this. The characteristic equation for A 3 by 3. So this is the highest degree quotient, and this is the second degree highest degree quotient, and this is the constant term. Okay, just write down the constant term of the characteristic polynomial. Characteristic polynomial, that is determinant of A. The constant term of characteristic polynomial is equal to determinant of A when the quotient of the highest degree is minus 1 whole power n. The constant term will be the determinant of A. Now please take down this for A 3 by 3. So minus 1 whole power 3 lambda cube plus minus 1 whole square trace of A into lambda square plus minus 1 whole power 1 del 1 1 plus del 2 2 plus del 3 3 into lambda power 1 plus mod A is equal to 0. So this is what the characteristic equation for 3 by 3 matrix. Now all of you, the question number, let's go to the question number here, T24. Yes, T24 dear. T24. So what is the answer for T24? Varun, constant term of characteristic polynomial. Okay, you are noted it. Very good. Okay, coming to the question number T24, the constant term of the characteristic polynomial of the matrix C. What is the constant term of the characteristic polynomial of the matrix is? See here, the constant term of the characteristic polynomial is given by what? The determinant here. So that means you need to find out the determinant of that 4 by 4 matrix. So anybody can say the answer for that T24? Anybody? Without using your pen on the paper, you can give the answer, my dear. Without using your pen on the paper, you can give the answer. So here, we know that here the constant term of the characteristic polynomial of A is equal to determinant of A. Right. This is what. So let's find out the determinant. It is 0. Dhruv Chatter, we don't need to go for 4 by 4 matrix. Okay. If I start writing it, then somebody will ask 5 by 5 and all. So if you want, so I will tell you in the break. I mean, after the, in the doubt session, I will tell you. Okay. Not now. So the dependent is the 0. Very good, beta. Very good. So this determinant is equal to 0 because there is a linear dependency. Are you observing or not? The third row is 2 times of the first row. Third row is 2 times of the first row. Therefore, the determinant is 0. So the answer is 0. So this is how you have to use, without using the pen and the paper, you can give the answer. So I hope everyone understood what is the importance of linear dependency. I hope you understand. So this is the way you have to use this linear dependency as a shortcut and getting the answers, right? Okay. Now let's move on to the next question. That is question number 63. 63 beta. Question number 63. Question number 63. Yes. Question number 63, if you see, A is a n by n complex matrix whose characteristic polynomial is f of t is equal to so and so, then what is this det A and all? Det A. So, according to the option, he is asking determinant. But we all know that, my dear, the determinant is given by the constant term in the characteristic polynomial. But the constant term in the characteristic polynomial is C naught. But actually, this is not in the standard form. Whether you observe or not, yes, the standard, see here, when you take the constant as a constant term as a determinant, so then what should be the coefficient of the highest degree term? The coefficient of the highest degree term must be minus 1 whole power n. But is minus 1 whole power n is there? No. So therefore, what do you have to do? What we have to do? Okay, right? Yes. So what we have to do is that. So in 63 question here, so as the since the coefficient of the highest degree term to be minus 1 whole power n, but it is not there. It is not there. So therefore, what we have to do? First, you multiply that minus 1 whole power n to the equation, and then it will be into this form, and then you take the constant as the determinant here. Okay, right. Now, minus 1 whole power n here. Now, so then we get the characteristic polynomial. Yes, what do you get the characteristic polynomial as? That f of t is equal to minus 1 whole power n t power n plus minus 1 whole power n cn minus 1 t to the power of n minus 1 t to the power of n minus 1 and so on minus 1 whole power n c naught here. So this is what. Now, so here, right? So here the coefficient of highest degree term is equal to minus 1 whole power n and so the constant term is equal to the determinant of A is equal to minus 1 whole power n c naught here. So the answer for this question is this. So please don't be hurry. First, you have to write the given equation into this format. Yes, into this format. If this minus 1 whole power n is not there, you are supposed to multiply and after that you take the constant as determinant. Otherwise, minus 45 will become plus 45 and you will get the wrong answer. So this is very interesting and important point you are supposed to remember. Okay, so now I'm going to do a one very interesting question here. The question is this: the characteristic polynomial of a 3 by 3 is lambda cube plus lambda square minus 21 lambda minus 45. So then find the first question here, that is mod of adjoint of A. Second one is adjoint of A. Okay, and third one is that A into adjoint of A. A into adjoint of A here is equal to what? So these all three questions I have to find from this question. So very beautiful question here. So if you do this question, so you will be getting the relation between all the things what you have studied. So you are going to connect the things what you have studied for this question. Now let's see this. The characteristic polynomial of a 3 by 3 is this. See dear students, so this is the characteristic polynomial is given and he is asking mod of adjoint of A. But you know students, mod of adjoint of A, that means determinant of the adjoint of A is given by determinant of A. You know that adjoint of A is given by determinant of A, and A into adjoint of A is also given by determinant of A. So since all these three is given by determinant of A, so by using the property of determinants, go back to and see. Okay, so all these are given by determinant of A. So therefore, I want to find out the determinant from this characteristic polynomial. But how to get the determinant from the characteristic polynomial? So to get the determinant from the characteristic polynomial, so that is given by constant term. But before taking the constant term as a determinant, you have to check whether the quotient of the highest degree term is minus 1 whole power n or not. If it is not, you rewrite, multiply it and make it standard equation, and then you take the constant term as a determinant. Be careful with this step. I'm telling you, be careful. See, if for a3 by 3 here, what should be the highest degree quotient term? The quotient of highest degree term for a3 by 3 must be minus 1 whole cube. But that means minus. But is it minus? No. So therefore what we have to do is that we need to multiply minus to this equation. So first what we have to do is that convert the polynomial into standard form. Convert the polynomial into the general characteristic polynomial. General characteristic polynomial by multiplying minus 1 whole power n, that is minus 1 whole cube. So then we'll have the characteristic polynomial of a 3 by 3 will be, yes, minus lambda cube minus lambda square plus 21 lambda plus 45 is equal to plus 45 here. So this is what the case, right? Now so therefore the constant term is equal to determinant of A. So the determinant of A is nothing but 45. So I got determinant of 45 beta. Okay. So right. Okay. Right. I got 45 here. I got 45. But now my question is that how to find out all these three adjoint of A and all these three here. Now, yes, let's go with the first question here. First question here, we know that adjoint of A, mod of adjoint of A 3 by 3 is given by mod A to the power of 3 minus 1. So that is 45 square. 45 square is the answer because 45 is the determinant. The second one is that we know that here adjoint of A 3 by 3 is given by here mod A to the power of 3 minus 2 into A. So that is 45A here. So this is the answer for this, right? Now the third question, my dear. Third question is what? A into adjoint of A. So what is the expression for A into adjoint of A here? Let's see. We know that, dear, A inverse is equal to adjoint A by mod A. Correct? So now, if I take adjoint of A is equal to mod A into A inverse. Correct? Mod A into A inverse. Now, to get the A into adjoint of A, what we have to do is that we need to multiply. Multiply A on both sides. Multiply by A on both sides. So, A into adjoint of A is equal to what? So, that is mod A into A into A inverse here. So, A into adjoint of A is equal to mod A into A inverse is I. So, that is nothing but 45I. So, this is the answer. 45I is the answer for this case. So, first question, second question, third question, all these three are given by determinant of A. So, where determinant of A is understood from the constant term of the characteristic polynomial. But before, be careful, my dear students, before taking the constant term as a determinant, check whether the highest degree coefficient is having the minus 1 whole power n or not. Please check that, all of you. If it is not, so please multiply it and then you take the constant term as a characteristic polynomial. Be careful with this. Yes, with this I am concluding the class today. Today the class is getting concluded because you have the class at 6 o'clock again. Now, if anyone has any doubts, so you can ask. So let me discuss the doubts. In question number 63, the quotient of other terms will also become same, but expression every term has minus 1 whole power n. Manvish Jindal, along with minus 1 whole power n in the second term, you will also see Cn minus 1. That Cn minus 1 is not given. It may be minus term or it may be plus term. So if it is minus term, so then minus 1 whole power n after multiplication of minus 1 whole power n, so it becomes minus 1 whole power n minus 1. Correct or not? Yes. So that way it will be. So don't worry. As Cn minus 1 is unknown, so we can multiply it and it will be converted into standard form. You can understand. Sir, only these two conditions should be there Yes, these two conditions are enough, Salil Kanna. These two, first condition is enough. Minus 1 whole power n is to be there. That is enough. बाकी सब automatically हो जाएगा. Got it? C will take care of that, sir. Okay. In generally, you told us to include the minor terms, but in characteristic equation of 3 by 3, we had minor terms. How, sir? Harshit Sharma, you don't understand that concept, बेटा. आप अगर आपको वो कॉन्सेप्ट में भी जाता है ना, थोड़ा सा आपको टिपिकल लगेगा क्योंकि और जानकारी चाहिए. So we should go more towards it. So that is why, okay, that will be there. But it is not that. What I told you is absolutely correct. But for lambda power n minus 2, it is not correct. So those minors will be will come just before the constant term. Just before the constant term for lambda coefficients. Actually, the sum of the minors will be the coefficients of lambda in any nth order equation. In any nth order equation. So the minors you will be getting. There is no question that the minor will not come. Minor will come, but they are not the coefficients of, some of them is not the coefficient of lambda over n minus 2. Some of them is the coefficient of lambda actually. That is why I mistakenly wrote, I told. Okay, very good. Many of the people have given correct answers. Thank you, Pradum. Leave us, we have the class at 5:30, sir. Already I left it. Banu Pratap, you can leave and attend the next class. Thank you. Thank you, Sekran. So tomorrow will be very interesting because the most of the we'll do maximum questions for our fort. So be ready for the questions tomorrow. No need of Ghosh. Ghosh, my notes is more than enough for for today's concept. I'm telling you. Tanmay Ghosh, you are saying that today's class seemed a bit more difficult for me. Yes, because I told you, na, you remove the part of that concept. Because there is a lot of derivation I have done. There's a lot of visualization of nullity and all I have done. Just remember the formula and apply that in the problems. That is enough. Don't go into the concept and detail. Okay, not required, Tanmay Ghosh. Tamogna Ghosh, sorry. Lambda power 4 means minus 1 whole power 4. That's it. Okay, bye-bye. Harshavardhan, please beta, it will take a lot of time. Don't kill my time. Already I said bye. Because we have only one equation, Anant Kumar Pandey. Because we have only one equation and 3 unknowns. So there is a need of finding the free variables so that for that many variables we need to assign some arbitrary constants. That is why you have to understand for how many variables you need to assign the constants, arbitrary constants. To understand that, we are using the concept of free variables. Thank you, Ankit. Tomorrow we'll see Munib. Tomorrow matrix should be completed. Thank you, sir, for the academic presentation. Have a nice evening and take care. Thank you, beta. I'll explain the eigenvector concept. The eigenvector in lambda is equivalent since the CS21 you told that X is independent. Then P is the independent vectors relating to. I'm getting doubts, sir. Arey, Bhavna, that is something different. See, for rank, we have to find out the independent vectors, na? So as P is a matrix, we are finding the independent vectors. Okay, right? But we in the for lambda is equal to 1, we are getting the solution of homogeneous system. The solution of homogeneous system is just like X. So here X is nothing but independent solutions of that homogeneous system. So it gives you nullity. Yes, you can leave Utkarsh. Yes. Yes, Salil Khanna. Yes, Salil Khanna. Yes. Yes. Correct. Yeah, आप ही सही. Thank you. Thank you. Thank you, beta.